And welcome back to Coast. Walter Cruttenden is with us, lost star of myth and time. Walter, of course, is the director of the Binary Research Institute in Newport Beach, California, and he researches the cause and consequences of solar system motion. Walter, how have you been?
Hey, terrific, George. How are you?
Good. I'm looking forward to this. The talk about a binary star system, by the way, in our solar system seems to be heating up again. What's going on?
Yeah, it's nice to hear some real legitimate scientists finally getting involved in this. Both Richard Muller out of UC Berkeley has been talking about it, Whitmire and Matisse out of the University of Louisiana, and, of course, the big guy is Mike Brown over at Caltech. What he's been looking at is this strange orbit of Sedna. This is the farthest most Kuiper Belt object, and one of the largest too. And he's come out and said, hey, this orbit can't exist without there being something else out there. There has to be either a big 10th planet or a dwarf star or something, but you just don't have these orbits exist for no reason out there.
Of course, and we know Zecharia Sitchin, the late Zecharia Sitchin, has always believed that we had that extra planet in the solar system someplace out there. So who knows, Walter? But it's exciting to think about.
It is, and with today's technology, they're making more and more discoveries, particularly Mike Brown and his team. And so I'm hopeful, sometime in the next few years, decade or so, we should have a big breakthrough and try to explain why these orbits exist. And my guess is it is because we're in a companion relationship.
And tell us what that would be. Explain to folks what a binary star system is.
Okay. Maybe 50, 75 years ago, they looked up in the sky and they saw these stars very close and determined that some of these stars were not just coincidentally close in the sky, but they actually orbited each other. And so it's two stars that are gravitationally bound. But it was thought to be a rarity. And but with today's technology, we're learning that these stars make up over 60% of the nearby sun-like stars, and perhaps, George, up to 80% of all stars if you start counting brown dwarfs and some of the very difficult-to-see stars.
80%? That's huge.
Yeah. And so we think, that it might have something to do with the motion we call precession, why we see the stars sort of rise in the west and set in the east over very long periods of time, as opposed to the diurnal and annual motions. And it could be explained if we're curving through space, if we're orbiting around another star, and it has huge implications.
When a star system is born, Walter, with that 80% number in mind here, when a star system is born, is it then a natural occurrence to have two stars in the system?
Some propose that this is the norm, that there's sort of a natural dualistic tendency in the universe, and that the single suns happen to have just lost their companion. And others aren't so sure of that. Nobody really knows for certain, but it could be that some stars would capture a companion now and then also. So the science is still very early on it, but the big thing is that it's realized that more and more of these stars are in these relationships, and if they are in these relationships, then it means, all sorts of things happen, cycles and things like that.
Now, how would that affect us on good old planet Earth?
Well, that's really the crux of our work here, what we want to talk about at the Binary Research Institute. And what we're looking at is, just as you have a cycle of day and night due to the Earth spinning on its axis, the diurnal motion, and just as you have the cycle of the seasons due to the Earth orbiting the sun on a slight tilt, so too, if our whole solar system is in orbit around a companion star, it might explain all this myth and folklore about this cycle of the ages, this rising and falling ages with, dark and golden periods. And over 40 different cultures talked about it. It's believed now, to be myth and folklore, but I really think that it may have a basis in fact, and the cause would be our solar system's motion around another star.
And now, is this a burned-out star?
It could be. There's sort of two schools of thought there, George. One is some astronomers are looking for a dark star, such as a brown dwarf, maybe a black hole. I mean, that'd be pretty unbelievable if there was one that close.
Oh my gosh, yeah.
Yeah, but or maybe even a red dwarf if it's just up against the galactic center, very difficult to see. Although that's unlikely because our technology is getting better and better nowadays. Or even a planet-like mass. I mean, there is stuff. We're learning that the composition of all these Kuiper Belt objects we're finding out there seems to be much more varied than they ever thought before. So that's sort of one school of thought. And then there's another school of thought which is perhaps a little bit on the fringe, but that is the idea that it might be a visible star, a nearby visible star. So it's something we see all the time, but just haven't realized that our motion can take us around it in a reasonable period of time. And so this implies that the solar system is moving faster than current estimates, but those estimates are always changing because, what do you measure it against? Everything's moving out there. And it also would suggest, that maybe we don't completely understand gravity as it gets into big space outside the solar system. And this is sort of an alternate explanation for, why the Earth precesses. In fact, that it's the whole solar system moving rather than just a local wobble, if you will.
Could it be responsible for catastrophes that we've had on this planet since the beginning of time, whether there was an Atlantis or not, the sinking of that continent, the Noah's flood? Could it have contributed to things like that?
There does seem to be a lot of myth and folklore about those things, and you would expect that if there is a big perturbing body that comes a little closer from time to time, that it would play a little bit of havoc with the Kuiper Belt. As a matter of fact, this Whitmire and Matisse that I mentioned, they believe that the sheer edge of the Kuiper Belt is due to this some other companion star, or brown dwarf is what they're guessing. And so, yeah, it could just as well knock out comets and things like this. Certainly, if there's upwards of 100 billion comets as estimated in the Oort belt, or in the Oort cloud, then it's possible that it would knock something like that loose from time to time.
The ancients, did they ever discuss the possibility of this?
Yes, and there's some wonderful work in that field, particularly this book, Hamlet's Mill, written by Giorgio de Santillana. He's a former professor of the history of science at MIT, and his co-author, Hertha von Deschen. She's an equally learned scholar out of Frankfurt University. And they wrote this book, published in the late 60s. They've both since passed away, but in there they documented all this myth and folklore about this common belief that history rises and falls, that there was a long-lost golden age, and that we'd go down and go into a dark age and then would come out again. And most of these cultures tied this cycle to the motion of the stars. And it's something today we call the precession equinox, and they didn't always use that term. They usually just said the movement of the heavens, something like that. But they would delineate it, and we knew they were talking about precession because they would say, that the equinox or solstice or some celestial marker would be in such and such a constellation. There's 12 constellations of the zodiac that surround the Earth roughly within 8 degrees of the ecliptic. And these are kind of used like markers, just like we use the numbers on a clock to tell where we are in the time of the day. Well, so too did these ancient cultures use these constellations, 12 constellations, to tell where we are in this cycle that Plato called the Great Year. And so, there's some beautiful myth and folklore, for example, Hesiod, the wonderful, the Greek poet. They call him a poet, but he considered himself a historian when he was talking about this long-lost golden age and how wonderful things were. And there's myths also in the Polynesian culture, Nordic cultures. There's just a wealth of information on this cycle. And so what we're trying to figure out is what causes it, how does it work, what are the observables, and we're just working on this 24/7.